Hello, everyone, and welcome to Precalculus. This is section 6.1, the law of sines. So up to this point, you've only known how to solve right triangles, that is, triangles that contain a 90-degree angle. Now we're going to begin the study of something called oblique triangles, which is just a fancy name for non-right triangles. To do that, we're going to use the law of sines. So for any triangle, A, B, C, we're going to put the capital letters in the corners to represent the measures of the angles. And then lowercase a, b, and c are the lengths of the sides opposite those angles. So if this is angle A, this is going to be side A over here. If this is angle C, this is going to be side C. And angle B will correspond with side B. And then the law of sines states that A over sine of A is equal to B over sine of B is equal to C over sine of C. Not that you'll use all three of these at the same time, but any combination of two of them will help you solve the problem. If for some reason it's more convenient for a specific problem for you to express these upside down, then the law of sine also works that way, whichever way works for the problem that you're trying to do. So let's do an example. Solve triangle ABC if A is equal to 63 degrees, B is equal to 49 degrees, and the length of side C is 78. So it doesn't matter where you put your A, B, and C, but since I wrote them here, I'm going to label this as 63 degrees. B is 49 degrees. And to find side C, remember that the sum of the measures of the angles in a triangle is always 180 degrees. So you can write down A and B and then solve for C that way. C turns out to be 68 degrees. So I'm just going to go ahead and fill that in. Now they also gave us side C, so I'm going to put that over here. It's across from the C. And now I need to find the lengths of side B and side A. So all you need to make the law of sines work is one matched pair, which we have. We have angle C and side C. So 78 is to sine of 68 as A is equal to sine of 63. So when you turn on your calculator, make sure that you are in degree mode, and then you can do 78 times sine of 63, divide that by sine of 68, and you'll get A is equal to 74.957. Although I see now it says the nearest tenth, so you can say A is equal to 74. Ooh, what are we going to do about that? So this would round up to 0, which would make this actually round up to 5. So the nearest tenth is actually 75.0. So I could use A again now that I know it, but it's better not to use pieces that you just figured out. Always use what was given. I guess the 68 wasn't given, but it was much easier to find in order to do another part. So I'm going to go back to this C over C one to get my B. So in case you didn't follow this last time, I guess I didn't actually write it out for you. I would multiply both sides by sine of 49. You guys have gotten good, so I didn't think to show it on the last one. So once you have this gone, you can do 78 times sine of 49 divided by sine of 68, and B is going to come out to be 63. It's actually 490, but since we're rounding to the nearest tenth, 63.5 is acceptable. So the three things that I found were angle C, side A, and side B. Okay, you might want to try the next one on your own, but of course I am going to do it for you. Since this is side B, I'm going to go ahead and label this angle B. And since I'm missing an A, this must be A, which means this is angle A, and corresponding to side C would be angle C. It's always easiest to find the angle first because the three angles add up to 180. So 180 minus 94.5 minus 48.3 is equal to 37.2. I have my first answer. Now that I have, do I have a matched pair? I do, I have the A. So I'm going to go ahead and do 39.4 is to sine of 48.3 is equal to, and now I can do either one. So I guess I'll just do B is to sine of 94.5. Again, to get the B all by itself, I'm going to multiply both sides by 94.5. And as long as your calculator is in degrees, you should be able to do sine of 94.5. Make sure you close the parentheses on your calculator. Then times 39.4 and divided by sine of 48.3. And B should come out to be 52.6. I would use A again, 39.4 over sine of 48.3 is equal to C over sine of 37.2. Again, multiply both sides by the sine of 37.2 to get the C by itself, and you should get C is equal to 31.9. I hope you're liking law of sines. Pretty straightforward, right? It gets harder. All right. So now I'm going to give you an example where you're only given one side. So in order, these are going to get trickier. So not all of them, but in order to make this work, put the known angle in the lower left-hand corner. So 47 degrees like that, and try to draw it kind of to scale. Okay. So if this is A and this is 47, and then this is 20, and then put the other side on the left, not on the bottom. It's not that it has to go there. It's just for the purpose of explanation, it'll make everything easier. So if that's side B, this must be angle B, and this must be angle C. Okay, so I have a known pair, so I can do 20 is to sine of 47 is equal to 12 is to sine of B. And this is what I meant on that first page where sometimes you might want to flip it upside down. So instead of doing this, you might say, oh, I want to get that sine B in the numerator. So law of sines works either way. Sine of 47 over 20 is equal to sine of B over 12. So my first step is going to be to multiply both sides by 12. And when I do this, I'm going to do 12 times sine of 47, and then I'm going to divide by 20, and I get sine of B is equal to 0.4388. It keeps going. In case you've forgotten from a previous chapter, the way we undo that, so you need the angle, but you have the ratio. The way you undo that is inverse sine. But I don't want you to try and type this answer in. I don't want you to, sorry about that. I don't want you to round at this point. So instead, use the answer button. It's right next to the enter. It's the second feature of the negative key. And that way you can get the exact answer, which is 26. It's actually 028, so just 26.0. Now that I have angle B, I can find angle C by doing 180 degrees minus angle A, which is 47, minus angle B, which is 26, and that gives me 107 degrees. Now that I have angle C, I can do, now see, I know the angle this time, so I'm going to go back to this form. So 20 over sine of 47 is equal to C over sine of 107. And when you multiply both sides by sine of 107, you can get that C by itself. And if you do that on your calculator, C will come out to be 26.1516, which rounds to 26.2. So there's all the pieces that I found. So angle C, and this is 85 degrees. You should probably draw it pretty steep to show that it's 85. And then I'm going to put the 15 on the other side. So if this is C and this is 85 and this is 15, then always put the other one, in this case B, over here, 25. So when I go to do it, I'm going to be finding the angle. So let's put the angles on top. Sine of 85 is to 15 as sine of B is to 25. I go to do this on my calculator. I multiply both sides by 25. And 25 times sine of 85 divided by 15 is 1.6603. Remember, you don't even have to write the whole thing, but you have to make sure that you keep the whole thing, do inverse sine of the answer that you just got to help you find B. And when you do that, you're going to get error. Why is it an error? Well, going way back to last chapter, remember that sine goes up to 1 and down to -1, up to 1 and down to -1. So sine is never bigger than 1. Sine is never 1.6603. So now you need to go back and look at your triangle and say to yourself, why didn't that work? Did I make a mistake? You didn't. It's just that if this is 85 degrees and this is 25, there's no way that this is 15. It's just not possible. If you're standing here and you decide to walk to this street over here and this distance is 25, you can't walk this way and suddenly have it be 15. I'll draw it even steeper. Remember, this is 90, so 85 is pretty close to 90, right? So if this is 25, no matter where else you go, it's going to be longer than 25, not shorter than 25. So this triangle is just an impossibility. There is no solution. Okay. All right, let's do the next one. Number 3. So again, I'm going to draw it in the lower corner. And this time it says A is 31. So B is only 12. So I'm actually going to draw B short. B is 12, 20.5. A is 31. It doesn't have to be perfect. It just needs to be somewhat correct. If you're always drawing triangles like this and then calling this 31 and this 12, you're going to have some trouble. It's going to help you to have it be slightly accurate. So I have a matched pair, which is all you need for law of sines. So I'm trying to find the angle. Let's put the angle on top. Sine of 20.5 is to 12 as sine of A is to 31. So you go to do the math and you get angle A is equal to 64 64.8 degrees. I won't go through that process again. Then, now that we have angle A is 64.8 degrees, then I can go ahead and subtract from 180. 180 minus 64.8 minus 20.5, and I get 94.7 degrees for angle C. So what's the only thing that's still missing? Side C. So to find side C, I'm going to say sine of 20.5. I don't use the A because I just found it. Maybe I found it wrong. So I'm going to use my given matched pair is equal to, this is going to put C on the bottom, right? So you can always flip it if you want to. Not a problem. Or you can deal with it on the bottom. Either way is equal to C over sine of 94.7. Multiply both sides by 94.7, and you'll get C is equal to 34.1. All right, this is the most important problem of the day. This is the hardest one in section 6.1. There's actually another answer. Everybody, when they draw a triangle, 9 times out of 10, draws it the way I drew it. But it is possible that I could have a 20.5 degree angle, and I could have this length be 31. But instead of drawing the 12 this way, I could have drawn the 12 this way. It didn't affect my angle, and it didn't affect the length. It just affected the way I drew it. So if I draw it this way, it changes everything. Angle C is tiny, side C is smaller, angle A is bigger. So the way you draw it is different. This one is going to have 2 solutions. And if you only get one of them, when you do a test or a quiz question, you'll only get half the credit. So you definitely want to learn how to do it this other way. So we start off same way. I still have a matched pair. Sine of 20.5 is to 12 as sine of A is to 31. You go to do the math, you multiply both sides by 31. And then after you get this number, you use your inverse sine of A to get angle A, and you get, 64.8 again. Of course you got it again. You did the exact same math. Okay, so I'm going to explain how to get the other angle A in 2 different ways. One of them needs to make sense to you. How to get the other angle A. Way number 1, you may remember that when you had sine of A is equal to a number, let's just say 1/2. But there are 2 possible answers. You guys used to write last chapter, well, that happens at pi 6, and you guys remember saying it's also equal to positive 1/2 in quadrant 2? So you gave me the quadrant 1 and the quadrant 2 answer. And that didn't bother you at the time. You knew that that made sense, that there were 2 places where sine was equal to 1/2. I realize 1/2 isn't the one here, but as a basic concept, you understood that. So that's the other answer here. Not only is 64.8 one of the answers, but 64.8 in quadrant 2. So here's 64.8. What is that angle in quadrant 2? It's over here, where this is 64.8. But I really need this big one right here. I need to know what that is. So how do you get that? You can do 180 minus 64.8. And it's going to give you the other answer, which is 115.2. Now, in case that didn't make sense to you, there is another way to think about it. And that is, I'm going to redraw the triangle the way you normally would. But I'm just going to give it easier numbers. So let's just say 5 and 11. If this is 5 in this direction, but then I choose to draw it that way instead, then this is what we call an isosceles triangle. Isosceles triangle means that the two sides have the same length. But what it also means is that the two base angles are the same. So if this base angle is 60 degrees, then this base angle is also 60 degrees. How does that help you? Because now you can find this angle, which is the other A. So this is the A your calculator is going to give you. Your calculator always gives you the quadrant 1 answer. That's what an inverse function will do. To get the other A, it's going to be this one over here, but if this is 60, this is 60, so this is 120. So let's actually put that in the triangle that we want, just more complicated numbers. So we have this as 12, 31, and this angle is 64.8. So if I draw the 12 in this direction, you see how that looks like isosceles? That means that this is also 64.8. And because these two angles are supplementary, this one is 115.2. In the end, how did I get that? They're supplementary. I subtracted from 180. So ironically, whether or not you're doing it using quadrant 1 and quadrant 2 or using it by this concept of the geometry, either way, the math you're going to do is 180 minus 64.8, and that's how you get the other one. But once you get this angle, you still need to go back and find all the rest of it. So again, got to make a little room. So this is C up here. Now angle C is going to be, well, I got to do the math here. 44, subtracting from 180, 180 minus 115.2, 20.5. This is going to be 44.3. And then you're going to have to find side C by doing C is to sine of 44.3 is equal to 12 is to sine of 20.5. And when you do that math, you'll get C is equal to 23.9. So in addition to getting this original set of answers, 1, 2, 3, when you draw the triangle differently, you have a whole nother set of answers that you need to get. Before we do some more examples, I just want to give a little summary to you. I think it might help you see how it all fits together. So if you're given angle, angle, side, remember that notation from geometry? That's where you have an angle, and then another side. Or if you're given angle, side, angle, that means you're given an angle, the side in between the other angle. You can use the law of sines without worry. But if you're given a side, and then just a single angle, that's when you have to check for this thing that they're calling ambiguity. That's when there could be two solutions, or one solution, or no solutions. So two solutions would be like the one we just did, where if you draw this height, and here's your angle M, which is acute, then this side M is less than this other side P. And that means you could draw the triangle like this, or you could draw the triangle like this. M could have been drawn this way. And people just generally don't think to draw it that way. This is the two solution case, one in blue, one in red. One solution would be if the height was exactly equal to M. So I always think of this as swinging either way. This M could go there, or this M could go there. But if M actually just is exactly the height, then that's going to have just one solution. If m is greater than p, so let's say p is small and m is large. In this case, that's the only way to draw it. You can't draw it p and then this way if m is bigger than p, because to draw it that way, m would have to be smaller. So that's why that one also only has one solution. And then no solution would be you have your p, you have your angle m, and then when you go to draw side m, it's not long enough. That's when you would have that no solution, and we did one of those. The other two cases are if m is obtuse. So obtuse means larger than 90. Here's my angle m. And now if m is less than p, so here's my p and here's my m, it's so short it doesn't even reach the other side. But as long as, so if this is distance p, as long as distance m is longer than p, you're going to go ahead and you're going to have one solution. So you might not totally get all those pictures now, but later on after you've done a few, this might be a good way for you to sum it up in your appendix. And if it doesn't help you, that's okay too. So let's do a few more examples and make sure that you got this. Number 4, C is 97. This is obtuse. Make sure you draw it as such. That means there's either going to be no solution or one solution. So I'm drawing it obtuse. Okay, it's a little bigger than 97. But there's my 97 degrees. Always put the other side, this is side A, on the left. And then start to draw yours. Okay, is it long enough? It says 45. As long as it's bigger than 39, it's long enough. Even if you didn't draw it to scale, that's all that you need. So good. I know I'm going to have one solution. If this had been 25, it wouldn't have reached, and the answer would have been no solution. But it is 45, so you can go ahead and use the law of sines. You might want to try this one on your own. But I take my matched pair, and I'm trying to find angle A, so I'm going to put the angle on top. So sine of 97 is to 45, as sine of angle A is to 39. And I won't put all the little details in this video, but angle A is going to come out to be 59.3. Once you have angle A, then you can do 180 minus angle A and minus angle C to get angle B, and angle B is going to come out to be 23.7 degrees. And then, so you find A first, then you find B, and then once you find B, you can set up another law of sines to find side B. So side B is to sine of 23.7, and even though you have a matched pair in A now, I would still go back and use your C since it was the original given. Sine of 97, which gives you B is equal to 18.2. All right, let's do another one. Angle A is equal to 114. Great, it's obtuse again. Make sure you draw it obtuse. So 114 degrees. A is 21, that's going to go on this side. And then B is 32. Hey, wait a minute. Can that be 32? If you're standing here and you walk to this street, if you cross over at this point and it's 32 feet, let's say, and then you decide, no, I'm going to cross over all the way over to there, can that possibly be 21? It cannot. So just by drawing it. But if you hadn't been paying attention or didn't draw it to scale, as soon as you had done sine of 114 over 21 is equal to sine of B over 32, you would have gotten an error. So this one has no solution. Okay, next one. C is 35. So I'm going to draw an acute angle. And C is 9.1 and B is 12. So I drew my 9.1 longer than my 12. So personally, I think it's better when you draw it just a little bit more accurate. 9.1, and then I made the 12 longer. This is what we call the ambiguous case. So I'm going to draw it both ways. Ambiguous case means you kept the 35, you kept the 12, and you kept the 9.1, but you kind of swung it the other way. And this is going to produce a different length here than it does this length here, and a different angle for A and B. All right, let's go ahead and label everything. This is C, this is C, this is B, so this is B. This is going to be A and angle A. Then on this one, this is still going to be angle A, but it's going to be smaller. This is going to be angle B, but it's going to be bigger. This is going to be side A. And I'll label my C over there. So here's the math for it. I'm going to find angle B. Sine of B over 12 is equal to sine of 35 over 9.1. And I get angle B is equal to 49.1, which means when I subtract from 180, my angle A is going to be 95.9. So then I can use that to find side A. So A over sine of 95.9 is equal to 9.1 over sine of 35. And A is going to come out to be 15.8. All right, so I've got all three pieces that were missing. But B could have been this angle here. So every single time you have two possibilities to get the other angle B, you're always going to do 180 minus. You can either think about that as because inverse sine produces two answers, or because of the geometry, that when you go like this, since this is 49, this is 49, and so now we can get the other one, which is 130.9. 130.9. That's going to be my angle B. If that's angle B, then you can subtract from 180 to get angle A, which is going to be 14.1. And then once you have angle A, remember this side is significantly shorter than the original A. So we got A is 15. This one had better come out to be shorter. So A over, because it's a little tiny angle, so it's going across to a little tiny side. Sine of 14.1 is equal to 9.1 over sine of 35. And we get 3.9. So it's a lot smaller. So notice two sets of answers. You must have them both. Number 7. So I always start with this angle in this corner. Here's 60 degrees. B is going to be over here, which is 14, and A is going to be 4, which is smaller than 14. So I think to myself, I had better draw this triangle twice. 14, 60, and then the 4 could be this way. So just to go through and label it, this is A, this is A, this is B, B is equal to 14, so this must be C up here. Now my red one, A, B, C. So I go to do the math. I need sine of b is to 14 as sine of 60 is to 4. When I go to do that, I multiply both sides by 14, and I get sine of b is equal to sine of 60 times 14 divided by 4 is 3.031. Now, you may not notice anything wrong at this step, which is fine. You would do inverse sine of answer, which is 3.031, and you would get an error. But maybe you didn't even get that far. Maybe you were like, hold on, sine can't be equal to 3. Sine is only ever as high as 1. So why though? I was able to draw the triangle. Well, if this is 60 degrees and this is 14, 4 is just so short, it just doesn't even reach the other side. Okay? So whatever the length of the height of this is, it's bigger than 4. So it didn't even reach the other side. So it is possible for it to have no solution, even if at first you think you're going to have 2 solutions. And again, that's why I made this little chart here. So you could have 2 solutions. You could have 1 solution if it's exactly the height or if it's longer, but there is the possibility of no solution if this one isn't long enough. All right, we're going to stop there. There is more for the law of sines, which includes word problems and using it to find area, but that's all we're going to do for today. So have a great day.